Hello, this is a tutorial for the Stellar Life Cycle Simulation. This is purely a kind of cool visual to show the formation of stars and what happens to them during their lives. And you can see there's a button up here for information. That is if you want my text, but if you don't like the way I've worded things, you can always just unselect that and say it however you like. This is, of course, not a fully realistic visual representation of what's happening, but here we go. Starting with a small star. Okay, yeah, you can actually reset it if you just double click on it. A star forms when a cloud of hydrogen gas condenses from its gravitational attraction. You just hit the forward button, and you can see it all kind of coming together and lighting up. So when it's gained enough mass and temperature, nuclear fusion begins and it produces light. Smaller stars, like our sun, are yellow dwarfs and can burn hydrogen for billions of years. So once it's progressed far enough into the animation, it gives you the option of going to the next one. Eventually, the hydrogen in a star's core runs out, leaving it with helium to burn. When it burns helium, it increases dramatically in size and cools to a red color. It's now a red giant. Now, this is definitely not to scale. The sun will grow to, I think I read something like 250 times its radius when it turns into a red giant, which, of course, I can't really show on here. Next is the once the helium runs out, the outer layers of the atmosphere evaporate, and you get your planetary nebula with a very hot, very dense core known as a white dwarf. So we get our white dwarf there. And then the next step is after theoretically quadrillions of years, a white dwarf will eventually completely burn its fuel, and it is now a black dwarf. So that is the small star. Going to a large star. I chose to make this one blue. A star forms, a cloud of hydrogen gas condenses from gravitational attraction. I made this one into a blue giant. Very large mass stars can burn hotter, bluer colors like this blue giant. And then eventually the hydrogen runs out, leaving it with helium to burn, and it can increase drastically in size and become a red or blue supergiant. Here we have a red or blue supergiant. Now, the supernova happens kind of fast, but here we go. And so once the helium runs out, a large star will collapse in on itself. The outer layer of the star explodes outwards in a supernova, while the inner core of the star condenses into an extremely dense and very tiny neutron star, and I gave it a little circle on it so you could see it rotating, although I think in real life they rotate at hundreds of hertz. I don't remember the number. And then, of course, that neutron star, if the star is massive enough, will continue to collapse into a black hole. And that's pretty much the end of the large star, and you can always hit reset and show it again. A size comparison. I just threw in a few stars here to show relative size comparisons, but of course there's huge variation in these. So this is showing perhaps the sun against a red giant against a red supergiant. Again, huge variations. And then we zoom in, and here's the sun as a yellow dwarf against Jupiter, Earth, Mars, and another white dwarf. And zooming in further, we've got Earth, which is about the size of some white dwarfs, I suppose, and the moon, and how big a neutron star and black hole would be if it was a one solar mass neutron star or one solar mass black hole in comparison to the moon. And that is the Stellar Life Cycle Simulation. I hope you find it useful.